Good afternoon. My name is Rodrigues and I came here to present my paper. The subject of my paper is Electric Battery Degradation, a Data Mining Approach. I have chosen this subject because it's a topic that it's both relevant and current. In recent times, we have assisted to the occurrences of climate changes of increasing intensity and reach. The destructive outcome of these changes are forcing us to switch to renewable energy sources and the development and adoption of more effective means of storing electrical energy. And one storage method are the lithium-ion batteries. Lithium-ion batteries have not yet reached their technological maturity or their largest capacity. They still have room for improvement, especially in their longevity. But because of that shortcoming, some myths still persist about their loss of capacity over time. This is especially noticeable in batteries, about batteries that are used by electric vehicles. And the persistence of these myths may actually deter the mass adoption of electric vehicles by the public, in addition to other factors. The research aim of my paper is then to identify the factors present in the data that are the most impactful to the premature decay of batteries. Also, it aimed to be able to measure and label the battery's decay rate. So, to answer the current problem, my paper proposed to answer the following research question: which behavioral habits from the electric vehicles may negatively impact lithium-ion battery capacity? My paper used a dataset that contained 1,500 contributions from EV drivers. This dataset was originally published on the Electrek website, which is a blog about electrical news, technologies, and breakthroughs. The dataset contained data submitted by private users from Europe, the Americas, from Asia and Pacific, and its data ranged from the years 2014 to 2017. It was organized in 43 variables, with data relative not only to the EV users but also to the car, to their mileage, to the frequency of daily travels, to their length of the travels, to the charging frequencies done, etc., and so on. My paper was then structured as follows. First, it included an introduction, where I present the problem at hand, the research question, and the data that I propose to use that will answer the problem. Then I include a second section that contains an analysis of the data. In this section, it is proposed the application of a data science methodology called CRISP-DM due to the sheer amount of data. This methodology is explained step by step later. It is also explained which machine learning models were used and for what purpose. And finally, I make the presentation of the results. Finally, the paper has a third section that lists the conclusions I reached, work limitations, and proposals for future works and improvements. Due to the considerable amount of data, I use a machine learning methodology called CRISP-DM. This methodology has 6 phases, as shown here by this flowchart. I approach the resolution of the problem from the point of view of a potential buyer of electric vehicles, a person who would wish to know which factors affect the batteries, the driving behaviors he or she can adopt to prevent early degradation, and as well as if it would be necessary some maintenance work or simply if he would have to replace the battery pack altogether anytime soon. Moving directly on to the third phase of the CRISP-DM methodology. This stage is about data preparation. So I had to execute the following steps. First, I had to check the contents of the dataset to understand the data. This table represents a sample of the 43 variables that were found inside the dataset. As you can see, it contained not only numeric fields with float and Boolean values, but also several variables that contain strings and texts. These string entries had to be converted to numerical values to be processed later by the classification models. I took the collected dataset and kept only the variables that were within the scope of the paper. So variables included were variables about the car, its features, like its brand, its model, its year, its current maximum range on a single charge, and its total kilometers. I also included some variables connected to the usage of charging and fast charging. All other variables were removed. Secondly, from these chosen variables, I made the necessary unit conversions, like converting miles to kilometers. There were many vehicles and users from the United States, so this was a necessary step for that country. Some date conversions were also necessary to be made. A third step was the removal of invalid or null values. These kinds of values were present in every variable. Finally, I also removed outliers from the dataset. My criteria for the removal of outliers was to remove all values that were above the 95th percentile and below the 5th percentile. The result of this cleaning process reduced the size of the dataset to roughly 1/3. So the dataset went from 1,500 observations to only 500 usable observations. It was an unfortunate result, but it was necessary to proceed. Over the resulting dataset, I remapped all the string values into numerical form. And finally, I applied 5 specific machine learning classification models. This table represents the reasons why some variables were rejected. As you can see, some variables contain personal information about the users, some add duplicate information that was already provided by other variables, and some were simply removed because they were out of scope for this paper. So I talked previously about the classification process. The classification process had the objective of identifying and labeling the rate of degradation of the electric vehicles present in the dataset. The degradation process had to follow certain steps. First, I compared the current range of each electrical vehicle as reported by its owner with the maximum range announced by its manufacturer for that model version when it was new. So this was necessary because some cars greatly differ, the same model greatly differs in maximum range throughout the years. And as an example, I quote the Nissan Leaf. The 2015 Nissan Leaf had a maximum range of up to 250 kilometers announced by its manufacturer, while a Nissan Leaf from this year, 2021, has currently a max range of up to 385. In this 7-year gap, the same model gained an increment of 135 kilometers to its maximum range on a single charge. And that's just taking into account 2 Nissan Leafs. All this difference had to be considered for all over EV cars present in the dataset. Afterward, I created a Boolean variable which I call degradation. Its function was to label the differences between the EV's original and current autonomy. If their difference was less than 10%, then the degradation would be labeled as normal. Otherwise, it would be labeled as abnormal. So where did this 10% value come from? it came from the literature review I performed for the paper. It justified this 10% value as an important metric, and it was actually the Electrac article that contained the link to the dataset that actually made this claim. It claimed that vehicles with more than 150,000 miles, or roughly 240,000 kilometers, suffered on average a loss of 10% to their original maximum range. Likewise, last year in early 2020, Tesla published their impact report. In this impact report, they stated their cars also suffered on average 10%, but after 200,000 miles. So, taking into account these two examples, I decided to use the 10% as a threshold to distinguish the 2 degrees of degradation. Then I applied the 5 classification models that are represented on the table on the right. Again, the literature review mentioned that these 5 models were the most suitable for smaller data sets. And since my dataset was reduced to only 500 usable entries, I decided to play it safe and use these models just as recommended. I then created confusion matrices for each model and calculated their accuracy with the accuracy formula shown below. So TP stands for true positives, TN for true negatives, FP for fake positives, and FN for fake negatives. And then I performed cross-validations to evaluate the performance of my models and to make sure the models were not overfitted to my data and could actually handle and use new data. On the right, the table shows the final results that were obtained with the testing set. The 2 models that obtained the best results were the logistic regression and the radial SVM, and are here represented in bold. While the table from the previous slide represented the classification models with the best performances, this one represents the importance that each of the chosen independent variables had over the dependent variable degradation. Of all the variables that are shown here, the variable here was the most impactful one. And that is because it was the only variable that was at the same time have shown to have a direct, positive, and significant correlation with the dependent variable. Regarding the conclusions of the article, I've reached the following results. First, I confirmed that the age of the cars is the only variable that had a negative impact on the car's degradation rate in a significant way, like I've shown in the last slide. Secondly, all other behavioral factors that were analyzed, and I'm talking about factors like frequency of fast charging, charging a battery to its full capacity, or letting a battery discharge completely, or even where the EV users park their cars, if indoors or outdoors. All these factors had a minimum effect on the maximum range of the EVs of the sample. It is true that some positive correlations were found between those factors and the dependent variable, but they were simply not significant enough. For future work improvements, I suggest working with a dataset with a larger number of responses. Even though 1,500 responses are an acceptable number, I would prefer to have more, simply because of the cleaning process of the data, which reduced the size of the dataset, like I said, to a third of its size. I also propose the addition of new dimensions to the paper. Dimensions like the field of electrochemistry, because there are plenty of literature in that field. One such example could be including the material composition of the battery's anodes and cathodes, Just this information could add extra detail to the conclusions. Also, future works could consider the inclusion of battery management systems, or BMS. These units register several factors such as external temperature, voltage, and the current the lithium batteries are subject to. It would also be important to add, for example, battery replacements as a factor. And finally, I suggest the creation and inclusion of user guidelines with a list of preventive actions that EV drivers can adopt to diminish the decay of batteries. And with this, I conclude my presentation. Thank you.